In this video, I'm going to quickly show you how to make a motion diagram from position time data. So a motion diagram is a way to represent the motion of an object by displaying its location or its position at equally spaced times on the same diagram. Motion diagrams are just visual ways to represent motion. So here I have two motion diagrams, and I want you to notice a couple of things that they always have. First off, they have some sort of coordinate frame, some sort of way to show different distances. So this top one is in feet, this bottom one is in meters, but notice it's almost like a number line. It is a way to show scale. And then on top, we have dots that are representing the position of an object at different times. So in this top one here, this motion diagram is showing that at 0 seconds, the object was located at a position of 2 meters. Then at 1 second, it was at a position of 4 feet. Sorry, this is in feet. At 2 seconds, it was at 6 feet, then 8 feet, then 10 feet. Down here, we have a similar motion diagram where we can show at all these different times an object was at all of these different positions. This is essentially what a motion diagram is. So you guys are going to construct a motion diagram from your position time data for your lab carts. And here is the basic thing that you need to do to construct a motion diagram. The first thing you should do is decide what scale do you want to use on this number line. Everyone is going to have different scales depending on what your data looks like. What I recommend you do is look at your position data and decide what numbers does this number line need to represent. I see my smallest number is negative 2.2 and my highest number is 3.9. So I'm going to have my number line range from negative 3 up until 4. That way I can fit all of my data on my number line. So you can go to your number line. I recommend you label it as position in meters so we know what we're talking about. I'm going to choose a starting location to label as negative 3. And then standard number line, I'm going to count over negative 2, negative 1, 0. Then on the other side, got 1, 2, and then 3, and all the way up to 4. So now I have my number line set up for position. Now all I need to do is essentially plot this data on my number line. So I know at time equals 0 seconds, my object was located at a position of negative 2.2 meters. So I'm going to find approximately negative 2.2 on my number line, say around here. And I'm going to represent my lab cart just using a dot. You do not have to actually draw an actual lab cart. You can just represent here the object was located at negative 2.2. So that's the position, but we also need the time. To represent the time, we are just going to label this dot t equals 0 seconds. So this piece of data, 0 seconds, negative 2.2 meters, is represented right here. The time is in the label, and the position is where it is plotted on the number line. So now if we move on to our next one, at 1 second, it was located at negative 1.1 meters, about here. So that's going to be time is equal to 1 second. Next one, we're at negative 0.1 right here. Now the beauty of a motion diagram is that these dots have to be shown at equal time intervals. So if the time in between these two dots was 1 second, these next intervals also has to be 1 second. So after we do these first two labels, 0 and 1, it is implied that this next dot occurs at 2 seconds. You don't have to label it, but you can go ahead and label it if you want. It's just not required. So we have 0, 1, 2. 3 is going to be over here at 3 seconds. 4 seconds is around here. 5 seconds is at 2.9 meters, around here. And 6 seconds is around here. So notice I did not have to label every single time. Again, it's implied 0, 1, 2, 3, 4, 5, 6 seconds. You do not have to label every single one. You only really have to label the first 2 or 3 to establish the pattern. And this is what your motion diagram should look like. Yours should look fairly similar to mine. You should have position and time but your numbers are going to be different depending on what your lab cart looks like. So again, just make sure you have labeled some sort of scale for position. So make sure you have labeled this number line. Make sure you have dots representing where the car is located. And finally, make sure you label some of those dots with the time.